Alright, listen up, you beautiful carbon-based lifeforms. Because today we are talking about the fact that everything you thought you knew about our neighborhood is a lie. Well, maybe not a lie, but we definitely missed a few structural details. It turns out the Milky Way isn't just floating in a void like a lonely grape in a dark room. No, according to some very smart, very tired people at the Captain Institute, we are actually embedded in a colossal, invisible, cosmic pancake. Welcome to the reality of the dark matter sheet. Now before we get into the invisible sheet part, let's talk about our neighborhood. In astronomical terms, we live in the local group. It sounds like a suburban gardening club, but it's actually a collection of about 50 galaxies, including us, the Andromeda galaxy, which is basically our overachieving twin brother. For decades, astronomers looked at the local group and thought, yeah, this makes sense. We're all held together by gravity, hanging out in these big, round, fluffy clouds of dark matter called halos. Because in the standard model of cosmology, everything is a sphere. Clouds are spheres, stars are spheres, and dark matter clumps are spheres. It's neat, it's tidy, and it's completely wrong. Enter Wemp and his team. They looked at the way our neighboring galaxies were moving and realized the math was acting like a teenager. It just wasn't doing what it was told. See, back in the 1920s, Edwin Hubble discovered that the universe is expanding. Galaxies are flying away from us. The further away they are, the faster they run. It's like the universe is a giant party and we forgot to wear deodorant. But there was a problem, a head-scratcher as the scientists call it. Andromeda is moving toward us. We're on a collision course. In about 4.5 billion years, we're going to merge into a Milkomeda, which sounds like a mediocre brand of European chocolate. Now, we knew why Andromeda was coming closer gravity. We're big, they're big, we're attracted to each other. Fine. But the other galaxies in the local group? Their movements were weird. They were defying the gravitational influence of the nearby realms. They were moving in ways that a simple spherical halo of dark matter couldn't explain. So Wemp and his crew did what any sane person does when reality doesn't match their expectations. They built a virtual twin of the universe. They didn't just guess. They took data from the cosmic microwave background. The CMB is basically the baby picture of the universe. It's the leftover glow from the Big Bang. By using this infant photo, the researchers were able to simulate the evolution of our local neighborhood from the very beginning. They hit play on the 13.8 billion-year-old VCR of existence and watched how the local group formed. And when they compared the simulation to the real world, the spherical halo model failed. It was like trying to fit a square peg in a round hole, except the peg is invisible and the hole is the size of several million light years. The only way the simulation matched reality, the only way the speeds and directions of our neighboring galaxies made sense, was if the local group was sitting in a sheet, a vast, extended, flat structure of dark matter millions of light years across. Wait, let's pause. What even is dark matter? Because we talk about it like it's a thing, but it's really just a name for we have no idea what's going on, but the gravity is definitely there. Back in the day, Fritz Zwicky looked at galaxy clusters and realized there wasn't enough visible stuff to hold them together. They should have flown apart like a wet dog shaking off water. He called the missing stuff Dunkelmattery dark matter. Later, Vera Rubin looked at how individual galaxies rotate and realized the stars at the edges were moving way too fast. If only visible matter existed, those stars should have been flung into the abyss. Something invisible was providing the gravitational scaffolding to keep the galaxy together. We now think dark matter makes up about 85% of all mass in the universe. We can't see it, we can't touch it, we can't taste it, and it doesn't interact with light. It's the ultimate cosmic gaslighter. It's there, but it refuses to acknowledge our existence. Traditionally, we thought this stuff clumped into halos, big, clumpy spheres. But Wemp's research suggests that on a local scale, we are part of a sheet. Now, why does the geometry matter? Because physics is a stickler for details. In a spherical geometry, gravity is fairly simple. The pull depends mostly on what's inside the sphere. But in a sheet-like geometry, everything changes. The researchers explained that the velocity-distance relation in a sheet depends not just on the mass nearby, but also on the mass at the distant edges of the sheet. Imagine you're standing on a giant trampoline. If it's a normal trampoline and someone puts a heavy bowling ball in the middle, you roll toward it. That's a sphere halo model. But now imagine the trampoline is being pulled tight by 20 people standing in a circle miles away. The way you move across that surface is now dictated by the tension from the edges. The mass at the distant edges of this dark matter sheet is pulling everything within it slightly outward. This explains the runaway motion of our nearby galaxies. They aren't just reacting to us. They're reacting to the invisible edges of the pancake we all live on. And what's beyond the sheet? Voids, massive, terrifying expanses of absolutely nothing. We are flanked on each side by cosmic voids where no galaxies reside. It's like living on a very thin, very crowded bridge over a bottomless pit. This discovery is a huge deal because it's the first real assessment of the distribution and velocity of dark matter in our specific neck of the woods. It confirms that our local environment is a bit of an outlier. We aren't just in a random blob. We are part of a highly organized, flat structure that is consistent with the cosmic web. If you zoom out far enough, the universe looks like a sponge or a spiderweb. There are long filaments of dark matter and gas, and where those filaments meet, you get galaxy clusters. Between the filaments? Voids. This new study shows that the local group isn't just a random speck. We are a part of one of these structural walls or sheets that make up the skeleton of the universe. So, what does this mean for you, a person who probably has to go to work tomorrow? Well, it means we finally have a model that reconciles the big picture of the universe with the local picture. It's like finally realizing that your house isn't crooked. You're just living on a very specific geological fault line that you didn't know existed. It also reminds us how much we still don't know. We are currently embedded in a substance that we literally cannot see. We are floating on a dark matter lasagna, being pulled by invisible edges toward a future where we merge with Andromeda. All while being flanked by literal nothingness. Is it scary? Maybe. Is it cool? Definitely. Does it make me feel like a tiny, insignificant speck on a cosmic crepe? Absolutely. The virtual twin simulation created by the team at Groningen is a masterpiece of digital archaeology. By using the light from the beginning of time to predict the movement of galaxies today, they've proven that the universe has a memory. The conditions at the Big Bang dictated that we would end up in this sheet. It wasn't an accident. It was written in the starting conditions of the cosmos. And let's give a shout out to Yud Wemp for the quote of the century. It is great that we now have a model that is consistent with the current cosmological model on the one hand, and with the dynamics of our local environment on the other. Translation: we finally fixed the math. And now we can stop arguing about why the neighbors are moving so weirdly. So, the next time you look up at the night sky and see the faint glow of the Milky Way or the smudge of the Andromeda Galaxy, just remember, you aren't just looking at stars. You are looking at the visible crumbs scattered on a massive, invisible dark matter dining table. We are all just riding the waves of a gravitational sheet, hurtling through the dark, trying to figure out where the edges are. It's crazy, it's improbable. It's slightly terrifying, but it's the reality of our local group. We are sheep people now, get used to it. And honestly, if we're going to be stuck on a cosmic structure, a giant invisible pancake is probably the coolest option we could have asked for. Just don't think too much about the voids on either side. Seriously, don't. Stay curious, stay slightly confused by the invisible scaffolding of reality, and remember, in space, no one can hear you scream about the math being wrong until you publish it in Nature Astronomy. And that, my friends, is the story of how our entire galactic neighborhood is essentially a flat earther's dream, but for real, and with much more dark matter. We're in the sheet. The sheet is us. And the universe just keeps getting weirder the more we look at it. Keep looking up, just watch out for the edges. They're pulling.